Hey, this is Mr. Molo for lesson 4-6, Arithmetic Sequences. So, you hear I pronounce that arithmetic. A lot of you are probably looking at it and saying it's arithmetic. So you're right. If it was like reading, writing, arithmetic, that's how it would be said. But since we're talking about the kind of sequence, it changes its pronunciation to arithmetic. And it has a definition right there for us. So arithmetic sequence is an ordered list of numbers in which the difference, kind of an important word, between each pair of consecutive terms on the number on that list is the same. So difference means we are going to be adding and subtracting every pattern here. So some of the questions on the homework and in this video will ask you just yes or no is an arithmetic sequence, and some of them might try and trick you. Well, they'll ask you, a multiplying pattern, and you'll be like, yep, I see a pattern, but it's a multiplying pattern. So then that's not an arithmetic sequence because it can only be adding and subtracting. And then the same number, so that's also a key role because sometimes it like adds 1 and then adds 2 and then adds 3 and adds 4, and we can see the pattern, we can figure it out. But again, that's also not an arithmetic sequence because it's not the same number each time. So like adding 2, adding 2, adding 2, adding 2 would be arithmetic because it adds 2 every time. So like if we look here, so use the figures to complete the table below, plot the points. So we're looking at the number of stars and how many sides it has. So if you look here, 1 star, and it's kind of hard to count because of how big the marker is on the tablet here, but 1 star has 10 sides. So that means if 1 star has 10 sides, 2 stars have 20 sides, 3 stars has 30 sides, 4 stars has 40 sides, and 5 stars has 50 sides. So then my pattern is adding 10 each time. Okay, kind of the same thing here. Count the number of circles. So on number 1 here, we have 2 different circles. On number 2, we have 3 circles. Then we have 4 circles, then 5 circles, and 6 circles. So we're adding 1 circle every layer. So then again, if it asks us how many would be on, the 37th circle, then we can kind of answer questions like that. Okay, kind of the same thing here on this example. So when n is 1, it has 2 dots. When it's 2, it has 4 dots. And then when it's 3, it has 6. And then 8, and then 10. So here, it looks like our pattern is to add 2 every time. Okay, so for most of these, we can just go in and figure out what the pattern is and kind of just write it out like that. If we ever get to one where it asks us what the 98th term is, then we're going to want to pay attention to this formula because odds are we're probably not going to want to count out 98 times. So we have this formula right here. So a sub 1 is the first term in the pattern. So like some of those started with, 2 circles or 10 star or 10 sides or whatever it was. So whatever the first term in the pattern is. N is the number we're looking for. So if it says find, the 4th term, I would probably just count it out and figure out what the 4th term is. I wouldn't use this formula. It's going to take a lot longer. But if it asks us to find like the 48th term, well, then I'm probably not going to want to add 2 each time until I get to the 48th term to figure out what it is. And then D is the difference, which is pretty much just the pattern. So what is the pattern? What's it going up or down by? Okay, if it's positive, if we're adding something every time, that means we're going to go up. It's going to be a positive number. If we're subtracting something, it's going to go down. It's a negative number. Very important to notice. I have no idea why, but the D is at the end of the parentheses, but you're still timesing it. I would like it a lot better if it was written like that because usually when it's in the front, then we know. But like the people who made this one to make it confusing and do all kinds of stuff like that. All right, so if I look here, it just wants us to write the next 3 terms. So again, here's an example. I wouldn't use that formula there. I would just figure out what the next 3 terms are. So first I have to figure out what the pattern is before I can figure out the next 3. So 1 to 8 to 15 to 22, it looks like I'm adding 7 each time there. And so if I want to figure out the next 3, 22 plus 7 is 29, plus another 7 is 36, plus another 7 is 43. So it's just asking us what's the next couple numbers. Here, same thing, 20 to 14 to 8 to 2. So it looks like I'm subtracting 6 there. So then my next number would be -4, then -10, then -16. All right, I'll do one more with you here, number 3. So from 12 to 21 to 30 to 39, looks like I'm adding 9 each time there. And then so if I add 9 again, I get 48 and 57 and then 66. Okay, so it told us here we're looking for the next 3, so I'm just typing in the next 3. Here it wants us to graph it. I'm not sure when we would ever use this really, but remember this is the first number, this is the second number, this is the third number, this is the fourth number. So I'm kind of using this as a graphing point here. So it's 1 and 1, 2 and 3. The third number is 5. Fourth number is 7. It would kind of look a little bit like that. And remember, they should always be linear because it's an adding and subtracting pattern. So some of the problems on the homework, they might want you to graph. Okay, here it says it wants us to determine if it's an arithmetic sequence. So is there an adding or subtracting sequence on each of these? So one way to tell is if it's a straight line, or we can kind of look at the numbers and see if they're going up consistently. So if I connect my dots here, I can tell that this one kind of curves. It's not going to be a straight line. It's not linear. Also, we can tell by looking at the y's here from 0 to 1 and 1 to 4 and 4 to 9. That's not a constant pattern. It's going up 1 and then up 3 and then up 5. Again, we can see a pattern forming like 1, 3, 5, but it's not the same every time, so it's not going to be linear. Here at number 14, it looks like that's going to be a straight line there. And then again, if we look at the numbers, 20, 30, 40, 50, yes, it is a constant pattern there. We're adding 10 each time. Same thing here. It looks like I can connect the dots, give myself a straight line. And if I look at the numbers 21, 18, 15, 12, yes, it's going to be linear. It looks like we are subtracting 3 each time. Okay. And then these last ones here, so this is where it kind of depends on the numbers here, how I would do it. So it's asking for the 10th term. So this one wouldn't be so bad. You know, if we look at like 17, they already give us the first term, the second term, the third term, the fourth term. So really I need to do it 6 more times to figure out what the pattern is. So we could just do the pattern 6 more times and figure out the pattern and figure out that 10th number. But let's get some practice in with using that formula that we learned earlier. Okay, so here I'm going to use this formula here. So A1, remember, is the first number. So my first number here is 43. Plus n, the number we're looking for, tells us to find the 10th number. I'm going to put a 10 in there for n. And d is the difference. And it looks like it's going down by 5 each time. So I'm going to multiply by a negative 5. Okay, so here it just wants us to write the equation here. So I'm going to end up solving this. So I have 43 plus 9 times negative 5. So then 9 times negative 5 is negative 45. So 43 minus 45 is negative 2. So if I end up doing 43 minus 5, I get 38. Minus 5 again, I get 33. Minus 5 again, I get 28. And if I keep doing that until I get to the 10th term, I'm going to end up with negative 2. Okay, so that's how I would solve it. But here, it just wants us to write the equation. So we actually did too much work here, but I wanted to show you how to do it. So here, if we have the equation, so this is still 17. So let's pretend that we don't know what number they want us to write for. So I'm going to leave that as an n. Okay, so I just left that as an n. So I would distribute here. So I still have 43 plus a negative 5n. Negative 1 times 5 is positive 5. Okay, and now I'm going to add what I can. I can add 43 and 5 because they're both just regular numbers. So that means my equation is 48 plus a negative 5n, or just 48 minus 5n. So now I could put any number I want in there. So maybe now it says, oh, find the 10th term. And then maybe you see in the homework 2 problems later, now it says, oh, here's another pattern, find the 40th term. Well, you already have the formula, so you can just put in 10 in there, do the first problem, put in 40 in there, do the second problem, and you can kind of see it. Okay, so no matter which way you prefer, like number 20, again, not going to be so bad. So here's the first, here's the second, here's the third, here's the fourth. So let's see if I can do this 5th, 6th, 7th, 8th, 9th, 10th. Okay, so it looks like I'm adding 3 each time. So the 5th term is 46. 6th term is 49, and then 7th term is 52, 8th term is 55, 9th term is 58, and the 6th term, or the 10th term is 61. So if we're looking for the 10th term, it ends up being 61. Again, not so bad when we're only looking for, the 4th or 5th or 6th or even 10th term's not so bad, but you're not going to want to do that when you're looking for the, 48th term to do it that way. If you're one of those kids, and I have a couple every year that just like to do it that way and write it out, and their whole, quiz and test is just them writing out all these numbers until they get to the 48th term or whatever, then I'm not going to tell you that's not a right way to do it, because it is perfectly fine. But if you use that formula, it's going to be a lot faster for you.